All right, welcome to part 2 of Life Cycle of a Star, where we learn about the different life cycles depending on how large the star is. SWABOT students will be able to describe the different phases of a star's life cycle, possibly illustrate or draw the phases. I'm going to ask you to do that in your notes, and to know which phases are for high mass versus low mass stars. All right, so we're going to talk very briefly about a very low mass star, and then we're going to talk about our own sun. So very low mass stars are about half the size of our sun and can live in main sequence. Remember, main sequence is when a star is fusing hydrogen and helium, and that is like their adulthood. They can live in main sequence for 80 to 100 billion years. So our sun is a medium size, but it's considered a low mass star. So we're going to talk about low mass star life cycle and high mass star life cycle. So it's considered a low mass star, but it's a medium sized low mass star. So our sun is going to live in main sequence about 10 billion years. And our sun has been in main sequence so far about 4.5 billion years. So it's not quite halfway through its life cycle as an adult. So after main sequence, the next phase of a low mass star's life is called a red giant. So the star starts running out of elements to fuse. And so what happens is it kind of loses control of its gravity. The core contracts, but then the outer layers expand. And this phase can last about 100 billion years. So they're red in color and very bright. After that phase, the outer layers keep expanding and expanding, and the core collapses and it loses control of its outer layers by gravity. The gravity can't hold on to its outer layers, and so they slowly drift off into space, the layers. The core is very hot and bright. So you can see the core right here in this nebula. This is called the Cat's Eye Nebula. This phase lasts about 20,000 years, which in the life cycle of a star is a very, very short period of time. And it's returning a lot of its elements. So the hydrogen, helium, and it keeps fusing heavier elements all the way up to iron. So all of those elements are returning to space. They're very beautiful. Planetary nebulas are very, very beautiful. And so, it's interesting to see their pictures online and pictures that the Hubble Space Telescope has taken of them. They're quite extraordinary. So after a planetary nebula, we get what's called a white dwarf. And the white dwarf is the core of the planetary nebula. So once all those outer layers have disappeared, we get the core left. And it is incredibly dense and very hot. Its gravity is 350,000 times the gravity of the Earth. After a white dwarf, so basically the white dwarf it's like, I would consider it old age for a star, but it is cooling off slowly. And as it cools off, it will eventually become a black dwarf. So think of like a coal in the fire, like a piece of wood. It's all, when the fire goes out, the coals are white hot. And then eventually they cool off to be black and they're cold. So a black dwarf no longer has any heat or light. It takes about 10 trillion years for a white dwarf to become a black dwarf, which is a very, very long time. And as our universe is not that old, it's not even 1 trillion years old, there are no black dwarves in the universe. So I think this is just a theoretical thing that scientists know will eventually happen, that these white dwarfs will eventually cool off and no longer have any heat or light. So that is the life cycle of a low mass star. Here is like a little chart of what our sun is going to do. So it was born, we're about right here, 4.5 billion years. It's going to continue in main sequence for another 5 billion years or so. It'll become a red giant and then a planetary nebula and then a white dwarf at the end of its life. So yes, our sun will gradually warm up, which may destroy our planet at some point, but that's billions of years in the future, so not something that we need to worry about. So here is a graphic of the evolution of a low mass star. We've got a nebula down here. We've got main sequence, becomes a red giant, a planetary nebula, and a white dwarf. So I would love it if you would draw this into your note page for low mass stars, and then we're going to talk about high mass stars. All right, high mass star is about 10 times more massive than our sun, and it stays in main sequence about 20 million years versus 10 billion. So they don't live as long as a low mass star. They basically burn hotter and they're larger, so they run through their like hydrogen faster than a smaller star. So quite a bit shorter life. So they stay in main sequence about 20 million years, and then after that they become a red supergiant, which is very much like what happens to a low mass star, but they're larger. So it's the next phase after main sequence. Stars running out of elements, its core contracts, the outer layers expand, and this phase for a high mass star lasts about 1,000,000 years versus 1,000,000,000 years for a red giant. They're red in color and very bright. At some point, the star runs completely out of nuclear fuel. It's fused elements all the way up to iron, and the core becomes so heavy that it can't handle its gravity, and we get an explosion called a supernova when the core collapses. So this phase, so the supernova lasts a second. It takes a few months for it to burn bright in space, and it takes a few years to fade away. So they're hard to see. We haven't seen a supernova in quite some time. I think there's some documentation of one. Some Chinese scientists wrote things down. I think it was like in the year 300 or something like that they maybe witnessed a supernova, a very bright light. Anyway, maybe one day we'll get to see a supernova and get it photographed. So after the supernova, after the explosion, we get a choice of two different things can happen. The first thing that can happen is that the core of the supernova can become a neutron star. So here's the core. It's kind of like similar to a white dwarf in a planetary nebula, right? In a low mass star, the planetary nebula, the layers move away, and we get the core, which is called the white dwarf. So here we have a supernova explosion, and then we get the core that's a neutron star that's left behind. It is the densest and smallest stars. 1 teaspoon would weigh 1 billion tons. So I can't even wrap my head around what that means, how dense that is. The gravity is 2 billion times the gravity of Earth. So the gravity presses so tightly, the pressure is so much that the protons and electrons combine to make neutrons. And that's where the name neutron star comes from. They are not very bright. But they are, like I said, they're very dense. The other thing that can happen after a supernova is a black hole. So if a star is very big, so only in the largest stars after a supernova, they can become a black hole. So a black hole is a large area in space with extreme gravity. The gravity is so extreme that not even light can escape it. And this is actually our first photograph of a black hole that just came out in 2019. It was taken with 8 Link telescopes. It is in another galaxy, 500 million trillion kilometers away. It's a very large, 3 million times the size of the Earth. So scientists know that these black holes exist, but they're hard to get an image of. Obviously, they're black. They're hard to get. They're very large. And sometimes very far away. So anyway, this is our first image of a black hole. So only very few percentage of stars will become a black hole. So we looked at the top part of this just a minute ago for small mass stars have this life cycle, and larger mass stars have this life cycle down here. So we still have the nebula, we still have main sequence, we have red supergiant, and then we have a supernova explosion, and then one of two things can happen after a supernova. It can become a neutron star, or it can become a black hole. So if you would draw this into your notes, pause the video and draw that in to your large mass star notes. And some discussion questions. So what stages of high mass stars are similar to low mass stars? What stage is our sun in right now? What stages are different between low mass stars and high mass stars? So what are the same, what are different? And what is the fate of our sun? What will eventually happen to our very own star that we call the sun? And then finally, our meme. So for you Avengers fans, even Thor lives in space. And just like everything else, including life cycle of the star, science rocks.